I want to talk a little bit about how to interface Triggy's serial output port with your experimental control computer and the software running on that computer. So on the back panel of Triggy, you have these two USB connectors, and then you have the digital input port. This is an auxiliary analog input port. So just ignore all those. What we're talking about for now is this USB serial port. So this cable will connect to a computer that is running your experimental control software. And on the experimental control computer, there will be a USB serial port that will be created in the device manager. So I've opened device manager here, and I'm logged in as local administrator, so I can make settings changes, but you'll need to be administrator in order to be able to do some of these operations. I've designated this USB serial port for the Triggy as COM1, and if I double click on that entry, you'll see it's recognized as an FTDI device, which is just a common name or manufacturer of serial interface devices. Under the port settings, the really critical thing is that I've set the bits per second, also known as baud rate, to 115200. So that's 115,200. And then data bits by default will be 8, parity none, stop bits 1, and flow control none for now. So the important part is to set that baud rate. If you're logged in as a user that is not administrator, you won't be able to change that, or you can change it, but it won't be an effective change if you do it unless you're administrator. So once you've set that and you say okay, that device becomes available to your experimental control software. So in this example, I'm going to look at the signals coming from Triggy in presentation. So when I open presentation, it's going to take control of that serial device. And as an example, all software will operate differently, but in presentation, I go to the settings tab. And the first thing I need to do is create a port that is an input port. I've already done it. And assign it to an input channel, or the reverse, assign an input channel to that input port. So I created this input channel on this screen at the bottom where it says port input channels, and created one called Triggy, and it is tied to a COM port, COM1, and the mode is data. Interpret as state changes is enabled. So once I've created that and associated it with an input port, presentation also gives me the option to test it. So when I enable this, you'll see that Triggy resets itself. So if you've set the port mode in Triggy but didn't make it the default, it will reboot into whatever the default mode is. I have my mode set to ASCII by default, I believe. Let's just make sure. So let's go over to the right-hand button. So I'm going to move right across the menus and go to Scope USB and go down to Serial Mode. Select, and my mode is set to ASCII by default. So for purposes of this demonstration, we'll start with the mode in as byte. We'll say select, set that as default. I have my response box connected to channels 5 through 8. So when I select a button here, you'll see that's interpreted as 5. That's channel 5, 6, 7, and 8. You'll hear a sound because the software is just prompting me that a button has been pressed. But of course, in your experiment, whether or not it generates a sound and whether it displays anything on the screen is really up to you. But you can see the input device as a COM port at baud rate 115/200. The buttons are recognized in the software. So that's one of the basic elements of interfacing Triggy to your computer. Of course, in this case, it's only necessary if you want the experimental control software to log these buttons. If you're really only interested in using Triggy to reflect this change out the TTL output port, that is always true by default. So when I press this button and that light illuminates, a pin on the digital output port is raised by default. Let's look at some of the other modes here. So I'm going to go back to Scope USB and select Serial Mode and change it to ASCII and say yes. So now when I press this key, you'll see that I have multiple codes coming across. 1, 2, 3, 1, 2, 3, 1, 2, 3. Suffice it to say that presentation is looking for a byte, and what we're sending it is an ASCII character, which consists of more information spread out over time. So that's not the right way for presentation to listen to this port. What would that mode be used for? Potentially, if you wanted to interface your Triggy to another program that is interpreting the input as ASCII, that could be useful. One example would be PuTTY. We'll get to that in a separate video, but for the purposes of using it with presentation, MATLAB, PsychoPy, PsychToolbox, most programs that read the serial port, you want to send data as a byte, and you want to interpret the input as a byte.